Next, we will discuss about the survival analysis. Survival analysis is an especially interesting and powerful technique. In terms of marketing science, it is relatively new, mostly getting exposure in the last 20 years or so. It answers a very important and particular question: when is an event, purchase, response, churn, etc. most likely to occur? I'd submit this is a more relevant question than how likely is an event to occur. That is, if a customer is very likely to purchase but not for 10 months, is timing information of value? Of course it is. Remember, time is money. Beware though, given the increase in actionable information, it should be no surprise that survival analysis is more complex than logistic regression. Remember how much more complex logistic regression was than ordinary regression. Conceptual overview of survival analysis is like this. Survival analysis was essentially invented by Sir David Cox in 1972 with his seminal and oft-quoted paper Regression Models and Life Tables in Journal of Royal Statistical Society. It's important to note that this technique was specifically designed to study time until event problems. This came out of biostatistics, and event of study was typically death. That's why it's called survival analysis. But what about those subjects that are dropped out of the study because they moved away or lost contact? If we are considering a set of people out of which a certain number were survived. Again, I'll go to the general use case. It was drug treatment. There would be, say, a drug study where a panel was divided into two groups. One group got the new drug and the other group did not. Every month, the test subjects were called and basically asked, are you still alive? And their survival were tracked. There would be two curves developed, one following the treatment group and another following the non-treatment group. If the treatment tended to work, the time until event was increased. One major issue involved censored observations. It's an easy matter to compare the average survival times of treatment versus the non-treatment group. And then the question is, what happened to those subjects who dropped off the study because they moved away or lost contact, or the study ended or not? Everyone has died yet. Each of these involves censored observations. The question about what to do with this kind of observations is why Cox regression was created, a non-parametric partial likelihood technique which he called proportional hazard. It deals with censored observations, which are those patients that have an unknown time until event status. This unknown time until event can be caused by either not having the event at the time of the analysis or losing contact with the patient. What about those subjects that died from another cause and not the cause the test was treating? Are there other variables that influence the time until the event? These questions involve extensions of the general survival model. The first is about competing risks, and the second is about regression involving independent variables. These will be dealt or discussed soon enough. A business case is here. At the end of the year, Scott called his team and the marketing organization together for a review and brainstorming exercise. This is something Scott believed every smart analytics pro should do. He was especially interested in how the analytic team was perceived as providing value last year and what might be done differently in the upcoming year. During the meeting, the marketing managers complimented Scott and his team for providing actionable insights. The results gave most of them a good bonus, and they wanted to get another one this year. They did not all completely understand the technical details, and Scott made the culture around that okay. He tried to make his team viewed as consultants, accessible, conversational, and engaged with the broader organization. Thanks, Scott, and turn to the Director of Consumer Marketing, Stacy. Where can we improve? What targeting would help you and your team? Well, we have a pretty good process now. We pull this based on likelihood to respond. It has worked well. Yeah, I'm glad of that. The lift charts from Logit helped us mail only as deep as we needed to. This gives both the best ROI in the company. But is that all we can do? Just target those most likely to respond? Scott asked, what else there? Stacy asked, checking her phone. Yeah, I'm not sure, Scott said. What do you need to know to do your job? So that's an essential question. What is exactly required for a person to do better in his job? One thing that would allow you to do your job better than before, a knowledge that gives you a tremendous advantage. So, one of the respondents said, I knew what product each customer would purchase in what order. That is, if I knew when he would purchase a desktop or a notebook, I would not send a lot of useless catalogs or email to him or her. I'd send them the most compelling mark-on at just the right time, with just the right promotion and just the right messaging to maximize their purchase. They all looked at her, then they nodded their heads, and Christina had talked to Scott about joining his team after she graduates. It sounded like science fiction, Stacy said. We would get a list of customers with the most likely time to purchase each product. Scott rubbed his chin. Yes, that's a prediction of when each customer is going to purchase each product. So imagine having a database code with the number of days until each customer is likely to buy personal electronics, desktop, etc. Christina said we would just sort the database by products, and those most likely to buy sooner would get the communication. But does that mean using regression or Logit or what? I don't know, Scott said. What do we do about predicting those who have not purchased a product? Is this probability to buy at each distinct time period? They all left the meeting excited about the new metric, but Scott was wondering what technique would answer that question. If they used ordinary regression, the dependent variable would be number of days until purchase of a desktop based on some 0 day, say January 1st, 2 years ago. Those that purchased a desktop would have the event at that many days. Those that did not purchase a desktop gave Scott a choice. Either he would cap the number of days at now, say 2 years from the 0 date, which means say 725 if they were on file from the day 0 date onward, as though that those that have not purchased a desktop would be forced to have the event at 725 days. Not a good choice. The other option would be to delete those that did not purchase a desktop, also not a good choice. Rule number never ever, under any circumstances, delete data. Never, ever. This is an off with their heads. Ignoring the time until the event-dependent variable could give rise to logistic regression. That is, those receiving a 1 if they did purchase a laptop and 0 if they did not. This puts them right back into probability that they all agreed that timing was more strategic option. So Scott concluded that both OLS and Logit have served severe faults in terms of time until event problems. It's important to make a clarification about a trap a lot of people fall into. Survival analysis is a technique specifically designed to estimate and understand time until event problems. The underlying assumption is that each time period is independent of each other time period. That is, the prediction has no memory. Some undereducated, unexperienced analysts think that if we are saying say trying to predict what month an event will happen, they can do 12 logits and have one model for January, another for February, etc. The collected data would have a 1 if the customer purchased in January and a 0 if not. Likewise, if the model was for February, a customer would have 1 if the purchase in February and 0 if not. This seems like it would work, right? Wrong. February is not independent of January. In order for the customer to buy in February, they had to decide not to buy in January. So this is why logit is inappropriate. But yes, logistic regression is appropriate for a small subset of a particular problem. If the data is periodic, an event that can only occur at regular and specific intervals, then yes, logistic regression can be used to estimate survival analysis. This requires a whole different kind of data set, one where each row is not a customer but a time period with an event. I still suggest even then, why not just use survival analysis? So, as mentioned, survival analysis came from biostatistics in the early 70s, where subject studied was an event of death. Survival analysis is about modeling the time until an event. Due to the nature of survival studies, there are a couple of characteristics that are endemic to this technique. As alluded to earlier, the dependent variable is time until event, so time is built into the analysis. The second endemic thing to survival analysis is observations that are censored. A censored observation is either an observation that has not had the event, or an observation that was lost to study and there is no knowledge of having the event or not. But we do know at some point in time that the observation has not had the event. In marketing, it's common for the event to be a purchase. Imagine scoring a database of customers with time until purchase. That is far more actionable than from logistic regression probability of purchase. Let's talk about censored observations. What can be done about them? Remember, we do not know what happened to these observations. We could delete them. That would be simple, but depending how many there are, that might be throwing away a lot of data. Also, they might be the most interesting data of all, so deleting them is probably a bad idea. We would just give the maximum time until an event to all those that have not had the event. This would also be a bad idea, especially if a large portion of the sample is censored, as is often the case. It can be shown that throwing away a lot of censored data will bias any result. Thus, we need a technique that can deal with censored data. Also, deleting censored observations ignores a lot of information. While we don't know when the customers they purchased, or we do know as of a certain time that they did not purchase. So we have a part of their information, part of their behavior. This should not ever be deleted. This is why Cox invented partial likelihood. The above is a general survival curve. The vertical axis is a count of those in the risk set, and it starts out with 100%. There is at time 0, everyone is at risk of having the event and no one has had the event. At day 1, that is after 1 day, 1% died and there are now 99 that are at risk. No one died for 3 days until 9 had the 7 at the day 5, etc. Note that about 1229 had the event. Now note that one survival curve is the same as above, but the other one is further out. 50% of the first curve is reached at 14 days, but the second curve does not reach 50% until 28 days. That is the leap longer. So survival analysis is type of regression, but with a twist. It does not use maximum likelihood but partial likelihood. The dependent variable is now two parts: time until the event and whether the event has occurred or not. This allows the use of censored observations. So much of Cox regression is not about the survival curve but the hazard rate. Hazard is nearly the reciprocal of the survival curve. This ends up as the instantaneous risk that an event will occur at some particular time. Think of metrics like miles per hour as analogous to the hazard rate. As 40 miles per hour, you will travel 40 miles in 1 hour if speed remains the same. The hazard quantifies the rate of the event in each period of time. It's worth mentioning that survival analysis is not just about the time until event prediction. As with all regressions, the independent variables are strategic levers. So we find that for every 1,000 emails we send, purchases tend to happen 3 days sooner. Do you see financial implications here? How valuable is it to know that you have incentivized a group of customers in making purchases earlier? If this does not interest you, then you are in the wrong career field. So Scott's team investigated survival analysis and concluded it was worth a shot. It seemed to give way to answer the key question: when is a customer most likely to purchase a desktop? The table above lists the final desktop model using LifeReg. The variables are all significant at 95% level. The first column is the name of the independent variable. The interpretation of LifeReg coefficient requires transformations. This gets the parameter estimates into a form to make strategic interpretation. As typically used on a database, each customer is scored with time until the event, in this case, time until a desktop purchase. The desktop is sorted and a list is designed with those most likely to purchase next. This time until event, TTE, time till event, is at the median. Note that customer 1000 is expected to purchase a desktop in 3.3 weeks and customer 1030 is expected to purchase desktop in 14.9 weeks. Using survival analysis allowed Scott's team to score the database with those likely to purchase sooner. This list is more actionable than using logistic regression where the score is just probability to purchase. Now let's talk about competing risks. While survival analysis is about death, the study usually is interested in one kind of death, or death from one cause. That is, the biostat study is about, say, death by heart attack and not about death by cancer or death by car accident. But it's true that in study of death, the heart attack as a patient is also a risk of certain other kinds of death. This is called competing risk. In marketing arena, while the focus might be on purchase event for, say, a desktop PC, the customer is also at risk of purchasing other things like a notebook or consumer electronics. Fortunately, this is an easy job of just coding the events of interest. That is, Scott can code for an event as desktop purchase with all else coded as non-event. He can do another model as a purchase event of, say, notebook, and all else is a non-event. That is, all other things are censored. As having a purchase event for a desktop, notebook, and consumer electronics are separate models. So a little technical background here. First, something to note about LifeReg is that it requires you to give it a distribution. In using LifeReg, it suggests testing all distributions and the one that fits the best is the one to use. Another view would be to acknowledge that the distribution has a shape and ascertain what shape makes sense given the data you are using. Pseudo R-square. Well, R-square as a metric makes no sense. A lot of analysts like some kind of R-square. To review, R-square in OLS is the shared variance between the actual dependent variable and the predicted dependent variable. In survival analysis, there is no predicted dependent variable. Most folks use the median as the prediction, and that's okay. I suggest running a simple model with and without covariates, that is, in SAS with proc life reg, run the model without the covariates and collect the 2-log likelihood stat. Then run the model with covariates and collect the 2LL stat and divide. This metric by analogy shows the percent explained over the percent unexplained. To conclude, survival analysis is not a common topic in marketing analytics, and it should be. While it's true that marketers and biostatisticians do not move in same circles, I've now given you some of the basics, so go and get to work. Next we'll talk about customer lifetime value. Typically, lifetime value is but a calculation using historical data. This calculation makes some rather heroic assumptions to project into the future but gives no insights into why a customer is lower valued or how to make a customer higher valued. Using predictive techniques here, survival analysis gives an indication as to what causes purchases to happen sooner and thus how to increase lifetime value. Lifetime value is typically done as just a calculation using past historical data, that is, it's only descriptive. While there are many versions of LTV or lifetime value, the following is conceptually applied to all, so I'll just describe the steps that works as follows. It uses the historical data to sum up each customer's total revenue. This sum then has subtracted from it some costs, typically cost to serve, cost to market, cost to goods sold, etc. This net revenue is then converted to an annual average amount and depicted as cash flow. These cash flows are assumed to continue into future and diminish over time, depending on factors like durability, sales cycle, etc., often decreasing arbitrarily by say 10% each year until they are effectively zero. These cash flows are then summed up and discounted to get their net present value. This NPV, or net present value, is called lifetime value. This calculation is applied to each customer. Thus, each customer has a value associated with it. The typical use is for marketers to find the high-valued customers based on first purchases. These high-valued customers get most of the communications, promotions, discounts, and marketing efforts. Descriptive analysis is merely about targeting those already engaged, much like RFM, recency, frequency, monetary, which we will discuss later. This seems to be a good starting point, but as is usually the case, the descriptive analysis contributes nothing informative. Why is one customer more valuable, and will they continue to be? Is it possible to extract additional value, but at what cost? Is it possible to garner more revenue from a lower valued customer because they are more loyal or cost less to serve? What part of the marketing mix is each customer most sensitive to? LTV, as described above, gives no implications for strategy. The only strategy is to offer and promote the only high-valued customers. So predictive analysis can be useful for LTV, and if it can be, we'll look at how. How would LTV change using predictive analytics instead of descriptive analysis? First, note that while LTV is future-oriented metric, descriptive analysis uses historical data, and the entire metric is built on that, with assumption about the future applied unilaterally to every customer. Predictive analysis specifically thrusts LTV into the future where it belongs by using independent variables to predict the next time into a purchase. Since the major customer behavior driving LTV is timing, amount, and number of purchases, a statistical technique needs to be used that predicts time until an event. Ordinary regression predicting the LTV amount ignores timing and number of purchases. Survival analysis is a technique designed specifically to study time until event problems. It has timing built into it and thus a future view is already embedded in the algorithm. This removes much of the arbitrariness of typical descriptive LTV calculations. So what about the survival analysis to see which independent variables say bring in a purchase? Decreasing time until purchase tends to increase LTV, while survival analysis can predict the next time until purchase. The strategic value of survival analysis is in using independent variables to change the timing of purchase or purchases. That is, descriptive analysis shows what happened, predictive analysis gives a glimpse of what might change in future. Strategy using LTV detects understanding the causes of customer value. Why a customer purchases? What increases, decreases the time until purchase, probability of purchasing at future times, etc. Then when these insights are learned, marketing levers shown as independent variables are exploited or extract additional value from each customer. This means knowing that one customer is sensitive to price and that a discount will tend to decrease their time until purchase. That is, they will purchase sooner, maybe purchase larger total amounts, and maybe purchase more often with a discount. Another customer prefers, say, product X and product Y bundled together to increase the probability of purchase, and this bundling decreases the time until purchase. This insight allows different strategies for different customers' needs and sensitivities. Survival analysis applied to each customer yields insights to understand and incentivize changes in behavior. This means just assuming the past behavior will continue into future, as descriptive analysis does, with no idea why, is no longer necessary. It's possible for descriptive and predictive analysis to give contradictory answers, which is why crawling might be detrimental to walking. If a firm can get customers to purchase sooner, there is an increased chance of adding purchases depending on the product. But even if the number of purchases is not increased, the firm getting revenue sooner will add to their financial value because time is money. Also, a business case can be created by showing the trade-off in giving up, say, margin but obtaining revenue faster. This means strategy can revolve around maximization of cost balanced against customer value. The idea is to model next time until purchase, the baseline, and see how to improve that. How is this carried out? A behaviorally based method would be to segment the customers based on their behavior and apply a survival model to each segment and score each individual customer. By behavior, we typically mean purchasing factors like amount, timing, share of products, etc., metrics, and Markham, open and click, direct mail, coupons, etc., responses.